Hey guys, welcome back. We're going to do 7-3 today, which is all about proving two triangles are similar, right? So we've done before, right, proving two triangles are congruent, but now we're going to look at seeing if we can prove that two triangles are similar, okay? So two objectives. Well, the first one is you should be able to use dilations and rigid motions to prove that two triangles are similar. And then we're going to use angle-angle similarity, side-side-side similarity, and side-angle-side similarity to prove triangles are similar. So new vocabulary, we're going to review what does it mean for two things to be similar. And then we're going to look at these new conditions here, angle-angle, side-side-side, side-angle-side. So let's go to the back of our packet and we'll go to the terms page first and we'll go over these. Okay, so here we are at the theorems and postulates page, and we're going to go down to angle-angle similarity. These are the three that we're going to look at today: angle-angle, side-side-side, and side-angle-side. I know that we've talked about these in terms of congruency, but we have not. Uh-oh, what happened? We have not talked about them yet in terms of similarity. So remember that similar, all it means is same shape, different size. Okay, so it's the same shape, it's just maybe one's bigger than the other. Okay, so the side lengths are not the same, but the angles will always be the same. So we have a couple different things here. So now the first one here is angle-angle. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Meaning if A and D are the same and B and E are the same, then I can say that these triangles are similar. Not congruent, similar. They're the same shape, just different sizes. So I can say that triangle ABC is similar, so we don't put the equal sign underneath because that means congruent. So it's similar to triangle DEF. What it basically automatically means then is that C and F are also congruent, right? But we just don't need to do the extra work to find that, because if two of the angles are the same, then the third angle is automatically the same. Okay. So just as a reminder, angle-angle did not prove that two triangles are congruent. Okay, it only proves that two triangles are similar. The next one is side-side-side similarity. So this is if the corresponding side of two triangles are proportional, not equal, proportional. If they were equal, then they would be congruent. Okay, but they can be proportional. So this is side A, right? Side B and side C. And then this is D, E, and F. And I'm going to let K be the scale factor. Okay, so what this, right, maybe I'm multiplying by 2, maybe I'm multiplying by 8, maybe I'm multiplying by 1/2, who knows, right? So side A times whatever my scale factor is will give me side F. Okay, and side B times whatever my scale factor is will give me side D. And side C I want to make sure that's right. That's not right. Hold on. Sorry. I'm getting real confused here. Okay, let's try this again. You guys are probably like, what the heck is she talking about? Okay, so side A, right here. If I multiply that by my scale factor, I will get side D. There we go. That makes more sense. Side B, if I multiply that by my scale factor, I will get side E. And side C, if I multiply that by my scale factor, I will get side F. There we go. That makes a lot more sense, right? Okay, and then the last one is side angle side. So this just makes sure that the angle is between the two sides. So if two sides of the triangle are proportional, again, not equal, proportional, and the angle between them is equal, then the triangles are similar. So here's my angle that I know is the same. So let's just say, right, C and A are what I know. And so then here, F and D are what I know. So if C times K, right, my scale factor, equals F, and A times K equals D, and angle B is equal to angle E, then I can say that triangle ABC is congruent, not equal, or sorry, similar, not congruent to triangle DEF. This is what I get for doing this while in pain and on drugs. Okay, not bad drugs, just like Tylenol and stuff. Okay, so ABC similar to DEF if I have side angle side. The angle, remember, has to be between the two sides. Okay, so let's go back to section 7.3 and look at how do we use these three theorems to solve problems. Alrighty, so let's look here at example 1. This says if angle A is congruent to angle R and angle B is congruent to angle S, is triangle ABC similar to triangle RST? And it says explain. So because I have an angle, right, angle, I can say yes, they are similar. And the explain can just be by saying by angle similarity. Okay, that's enough. That's a theorem. You can use that to explain your reasoning. So go ahead and try this one. It says triangle ABC has angle measures that are 59 and 61. It doesn't say which angles are 59 and 61, and it kind of doesn't matter, okay? So just label it. And then triangle DEF has angles whose measure are 60 and 61. Are they similar? So I want you to go ahead and try this. Maybe find the third angle in each triangle as well, and then determine are these two triangles similar. When you're ready to go over it, hit play. Okay, so hopefully you guys tried this on your own first. This says triangle ABC has measures that are 59 and 61. And then DEF has 60 and 61. Again, it doesn't really matter what angles are what. So, and it doesn't tell you, so. Okay, so right now I cannot say that they're similar, right? Because their angles are not the same. One of the angles is the same, but the other one is not. I'm going to go ahead and use the fact that the three angles of a triangle add to 180, and I'm going to find the third angle. So if I do 180 minus 61 minus 59, right, I get that C is 60, and if I do it over here, I get that F is 59. So are these triangles similar now? Yes, right? All three of their angles are the same. So we can say yes, triangle ABC is similar to triangle DEF by angle similarity. So sometimes if the angles are not automatically the same, you might have to find that third angle to see if then they are the same. Okay. Hopefully that's not so bad here. We're gonna kind of move on to side. Okay, so example 2. This says LM over PQ, so a ratio of LM over PQ, so those tell me that those are the same, is equal to MN over QR and is equal to LN over PR. So because those ratios are set up, I can say this. And then the question is, are they similar? We can say yes. These scale factors are the same. Right? It's not telling me that, sorry, and I shouldn't say with the tick marks it looks like they're equal, right? But that's just proportional. That's why it's set up as a fraction. The scale factors are the same. So triangle PQR is similar to triangle LMN by side similarity. Okay, I want you to try the next one. I'm going to scroll down here. Try the next one. Oops. See if you can do these two, and then when you're ready to go over them, hit play and we'll review it. Okay, so let's look at the first. Try it. It's saying DF and G, D to F and G to H, G to J are proportional. Okay, so for example, this could be 2 and this could be 4. And then EF and HJ are also proportional. So this could be 1 and this could be 2, for example. And then F and J are congruent. Is triangle DEF similar to triangle GHJ? That's really hard. Yes, right? So these two are similar. So we can say yes, triangle DEF is similar to triangle GHJ by, remember our 3 are either angle, angle, side, 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 or side, angle, side. In this case, it's side, angle, side. So side, angle, side, similarity. Okay. And then our last try here, it says in triangle ABC, A is 3. Ooh, that's hard to read. I'll just write it next to it. A is 3. B is 4. C is 6. In DEF, D is 9. E is 12. F is 18. Are these two triangles similar? So we have to find the scale factor. We have to see what do you multiply by to go from one triangle to the other. And that scale factor has to be the same on all 3 sides, right? So what I usually do is I follow this. So side A to B, which is C, which is 6, corresponds with DE, which is 18. So I can do 6 over, I said 6, 18 over 6, which is 3. Okay? And also in this triangle, side BC, which is A, corresponds to side EF, which is 9D. So I get 9 over 3, which is 3, which means the last 2 sides are corresponding. So that would be 12 over 4, which is 3. So since the scale factor is the same on all 3 of these sides, that means that they're proportional. And so yes, it is similar. Yes, triangle ABC is similar to triangle DEF. By, now we have to decide, is it angle, angle? No, I don't know any angles. So then it can't be side, angle, side either because I don't know any angles. So it must be side, side, side similarity. Okay, so since all three sides are proportional to each other, then it's similar. So same shape, just different size. All right, let's keep cruising. Okay, so now we're going to verify, are these triangles similar? So keep on cruising, okay? So let's look at part A. It says, are A, B, C, and D, E, F similar? And they give me the values. So I'm just going to have to go through and set up my proportions and see if they're the same, right? So again, I'm looking side AB corresponds to side DE. So that means that 4.5 over 3. I usually like to do the bigger number on top, but it doesn't really matter. You can do it the other way too. You can do 3 over 4.5. So 4.5 divided by 3 is 1.5. Okay. Then the other two sides are BC, which is 4, and EF, which is 6. Then I have 6 over 4, which is also 1.5. So far it's looking good. And then my third side would be the 7.5 over 5. And if I divide that, I get 1.5. So the scale factor here is 1.5. So since I multiply all three of my sides on ABC by 1.5 to get all three of my sides on DEF, then these are similar. So triangle ABC is similar to triangle DEF by side, side, side similarity. Okay? Part B says triangle PQS. I'm going to draw these separately. Whenever I have triangles that are like combined like within each other, sometimes it's really hard to see. So I'm going to draw these two triangles separate, like so. Okay? And I know that this full length is 15 plus 12, which is 27 and 18. Okay, so triangle PQS and RQP. So this guy, and this is P, this is Q, this is 18, and this is R. And I know this is 12. Okay, so I only know two sides, but what I have, and this happens quite often, when you have triangles that are stacked within each other, notice here the angle Q is the same angle in both triangles. So I actually know the angle Q is the same in both triangles because it's the exact same angle here. So when I look at this, I need to see if the proportions are the same, right? The only possibility here would be side, angle, side, because I don't know two angles, so I can't use angle, angle. And I don't know the third side, so I can't use side, side, side. So the only possibility would be side, angle, side, which might work. I do have two sides and one angle. I just have to make sure that my ratios are the same, right? My scale factor is the same. So this is where I use, again, the order. Side PQ and RQ are the two sides that correspond. So RQ, and the order doesn't matter. So PQ is 18 over RQ is 12. So 18 divided by 12 is 1.5. Okay. Then the other side that's the same, or that correspond, QS, which is 27, over QP, which is 18. So you see how I'm using the order that it's written in to help me figure out which sides are corresponding. Which this also is 1.5. So since my two scale factors are the same, right, I get 1.5 on both, and this angle is congruent, I can say that these are congruent. So triangle PQS QS, not congruent, similar, sorry, is similar to triangle RQP by side angle side similarity. So I really do think that it's helpful to draw the two triangles separate and to make sure that you pay attention to the order that it's written in to help you figure out which sides correspond to each other. You guys have a try it here. It's pretty much identical. So again, it might be helpful for you to draw the two triangles separate. Go ahead and hit pause on this, and then when you're ready to go over it, after you've tried it, hit play. Okay, so if it helps you, hopefully you drew two separate triangles. If it doesn't help you, then don't worry about it, okay? But let's look. It says, is ADE, so ADE, similar to ABD? So on ADE, I have all three sides, no angles. And on ABD, I have all three sides, but no angles. So I can't use angle, angle. Well, I guess I have one angle in ADE, but I don't have any in ABD. So I can't use angle, angle, and I can't use side, angle, side. So my only option would be side, side, side. So then I would have to make sure that all three of my sides are proportional. So I'm going to look, and it says that AD, maybe I'll write it this way, AD is proportional to AB. Do you guys see that? AD is proportional to AB. Or you can write this, AB is proportional to AD. The order does not matter, but it's these first two letters in the first triangle and the first two letters in the second triangle. Okay? So whichever way works for you. I tend to like to do the bigger number on top. So AB is 3.2 and AD is 2.4. So I'm going to do the bigger number on top. So 3.2 over 2.4 gets me 1.33 repeating. Okay, now I'm going to do it again for the second two letters. DE is proportional to BD, right? Those are the second two letters. And again, you can switch those. The order does not matter. So again, I usually like to do the bigger number on top, but whatever works for you. Okay, so here B to D is 2.4 and D to E is 1.8. So I'm going to do the bigger one first. So 2.4 over 1.8. And if I divide that in my calculator, I get 1.33 repeating. Okay, so this is looking good. Then the third side is the first letter and the last letter. So AE should be proportional to AD. And again, you can switch the order, right? You can do AD first and AE second. It doesn't matter. Well, AD is 2.4 and AE is 1.8. I've already done that. I did it up here. And that's 1.33 repeating. So since they have the scale factor on all three are the same, right? It's 1.33. I can say that triangle ADE is similar to triangle ABD by side, side, side. Congruency. Similarity. Wow, sorry, I'm going to do that a lot. Okay. And then part B is ADE similar to BDC. So let's look at that. AD and BD, so AD and BD are similar. Again, I can switch it if I want. Doesn't really matter. So AD is 2.4. BD is 2.4. Okay, so I get 1. Then I'm going to do DE is similar to DC, right? The second two letters, the last two letters. And again, I guess the order doesn't really matter. You can flip them if you want, but DE is 1.8 and DC is 1.4. And if I divide that, apparently I haven't done that yet, 1.8 divided by 1.4, I get like 1.29-ish. So I don't even have to do the third side, which is fine because I don't know it anyway. But since 1 does not equal 1.29, blah, 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 the scale factors here are not the same. So no, they are not similar. The scale factors have to be the same in order for them to be similar. So hopefully that's making sense so far. Sorry, my computer keeps falling. Let's look at example 4. As always, if you have any questions on any of these examples, just make sure that you reach out. Example 4 says, what is the length of MN? So this guy right here. Okay, so I'm first curious on what's going on with these triangles. Remember that angle L and angle L are the same because of vertical angles, right? We have to think back to our previous lessons. Vertical angles. And I have these two sides are equal, and these two sides are equal. So isosceles triangle, and then 75 to 1, which means this is also 75 and 1. So they're proportional. So I can say that triangle JLK is similar to triangle MLN by side angle side similarity. So since that's the case, I know that 75 over 1, that's my ratio, is equal to 75 over 1, but I don't have to write it twice. And it's equal to 10 over, let's call it x, right? My sides are all proportional, so I can write this is equal to 75 over 1 again. I can write all three sides are proportional. I just don't need this because it doesn't really help me solve it. I only need 1. And then how do I solve a fraction that has an equal sign in between it? Right? Cross multiply and solve. So I get 75x is equal to 10. Divide by 75. Divide by 75. I get x is equal to 10 over 75. That fraction does reduce. I can divide by 2. And I get 2. Oh, sorry. No, I can divide by 5. Huh, not 2. 10 divided by 5 is 2. I'm ahead of myself. 75 divided by 5 is 15. So x is 2 over 15. So our two triads are going off of this same image. It's just saying if JL were 150 instead of 75, how would MN be different? So you're just solving the proportion. And then if JK was 20 instead of 10, how would it be different? So you're just solving the proportion. So just use the same proportion, but modify it according to the changes. And then when you're ready to check your answers, hit play on the video and we'll go through it. Okay, so let's check our work here. This is saying if this was instead of 75, it's 150, how would it change? Well, then the ratio would be 150 over 1, since I know these two sides are proportional, equals 10 over x, and this is still x. And I would just cross multiply here. So I have 150 over, 150x equals 10. Divide by 150, divide by 150, and I get x is equal to 10 over 150. The zeros can go away, and I just get 1 over 15. So x would just be 1 over 15 instead of 2 over 15. Then it says, so I can get rid of this because we're on a new problem. Then it says if the measure of JK were 20 instead of 10, so now this is 20, how would the value of MN be different? So I set up my ratio again. So 75 over 1 is my proportion. And then instead of 10 over x, it would be 20 over x. Remember, since I start 75, which is on the big triangle, I go big triangle to small triangle. Then on the other side of the equal sign, I have to go big triangle to small triangle. So you just have to remain consistent in your order. So I cross multiply, 75x equals 20. Divide by 75, divide by 75. I get x is equal to 20 over 75. If I divide both of those by 5, I get 4 over 15. So x would be a little bit bigger. So hopefully that makes sense, you guys. We're just setting up proportions, right? One side is proportional to one side. That has to equal another side proportional to the other side. They just have to be corresponding sides. So let's continue on. Same idea. This is our last example. And it says, Avery puts up a radio antenna in his yard. Ella tells him that their city has a law limiting towers to 50 feet in height. How can Avery use the length of his shadow and the shadow of the tower to show that his tower is within the limit without directly measuring it? I should say directly. Sorry, that's weird. So I'm looking here, and I have two triangles that are similar because of angle, right? Here's this, and then here's this. So I can say that triangle ABC is similar to triangle RST by angle. So that's good. I know these two triangles are similar. So since they're similar, their sides are proportional. So this is what I'm trying to find. I'm trying to find the height of the tower. So let's look. I know the distance of both shadows, and I know the height of Avery. So I can set up a proportion. There are multiple ways you can set up this proportion. I'm going to set it up big triangle to small triangle. So I'm going to go 40 over 5 is equal to, so I went big triangle to small triangle on corresponding sides. So that's equal to big triangle, which is x, height, over small triangle height, which is 6. This is the one I'm going to solve, but I want to show you there's other ways you can set this up, okay? You could have switched it. You could have done 5 over 40. You don't have to write this down, but I just want you to be aware. 6 over x, so you could have switched those. You could have done 5 over 6, right? Shadow over height is equal to shadow over height. You also could have done height over shadow in the same triangle is equal to height over shadow. So there's lots of different ways that you could have set up this proportion, okay? If you set it up differently, totally fine. You should get the same answer. So we're going to cross multiply. 40 times 6 is 240. 5 times x is 5x. Divide by 5. Divide by 5. And I get 48 feet equals x. So the tower is within the law because it's not over 50 feet tall. Okay? So his tower is within the 50-foot limit, right? His tower is not taller than 50 feet, so he's okay. Okay, you guys are going to do a try it. I'm going to scroll down. Same image, okay? Says if the tower were 50 feet tall, how long would the shadow of the tower be? So now this is saying we don't know what this is. This is x. And if the tower was 50 feet tall, how long would the shadow be? So same idea, you're going to set up a proportion and then cross multiply and solve. Go ahead and hit pause, do it real quick, and then we're going to check your work here when you hit play. Okay, so there's multiple ways you could have set up this proportion, right? You could have done height over shadow of the small triangle equals height over shadow of the big triangle. Or you could have flipped that and done 50 over x equals 6 over 5. You could have done shadow over height is equal to shadow over height. You could have done shadow over shadow equals height over height. Or you could have done height over height. Oh, sorry, we already did that. Or you could have done, oh, the reciprocal of this, right? Shadow over shadow equals height over height. Sorry, we're all confused. There. So there's multiple ways that you could have done it. I usually go across the triangle. So my first instinct would have been to do 5 over x equals 6 over 50. But any of these will get you the right answer. Okay. I'm going to cross multiply. So I get 6x equals 250. I divide by 6, divide by 6. I do get a decimal here, and that's okay. I get x is about 41.67 feet. So the shadow, right, it's a word problem, so we have to answer in a sentence, will be about 41.67 feet. So when you're setting up these proportions, there's not just one right way. Any of these 4 proportions would have gotten me the same answer. So it just depends on how you see it and how you like it. Okay, that's it for 7-3. As always, if there's any questions or if something doesn't make sense on this, make sure you reach out, and we'll see you guys next time.